here we have notes for 7-2. And again, we worked through those classwork practice problems first, and then we came to do this. So we talked about exponential growth being the numbers or the values are increasing by more as they get larger. If we go back and look at yesterday or earlier, our area pieces here, if we're going from 64 to 48, the difference between 64 to 48 is 16. So from one to the other, we're minusing 16. From 48 to 36, that's minus 12. From 36 to that last one, which we found to be 27, 36 minus 27 is 9. So notice, not decreasing by the same amount. So if I come back to this page, so with exponential decay, what we have going on here is that the values decrease slower or decrease by less as the inputs, those x values or time, that independent variable, as the inputs get larger. The values decrease slower as the inputs get larger. When we're looking at this, the base, again, that number being raised to the exponent, in order to make something smaller, when you're multiplying by something, in order to take what you start with and make it smaller, it's going to have to be, the base will be less than 1, but also greater than 0, because we're not going to have any negative numbers in there. It's going to be, well, what kind of numbers are less than 1 but greater than 0? Those are our fractions and decimals. But keep in mind, not all fractions and decimals. You can have fractions that are larger than 1, right? If I'm talking about 5/4, that's an improper fraction, larger than 1, the decimal 1.25. So not all fractions and decimals, but the fractions and decimals that are smaller than 1. All right, so example number 1, let's go ahead and sketch a graph. And then we can find the average rate of change just like we did last time. So again, going to my calculator here, I've got 24 parentheses 1 divide 3 raised to the x. So I'm gonna zoom out. Actually, instead of zooming out, I'm just gonna zoom standard so I don't have to deal with that again. All right, so again, just like last time, that exponential curve, it starts off really, really, really steep and then just kind of slimmers down. Looking at some points here. Yeah, I'm gonna go up by 10s just like I did last time. And again, when you're going up by 10s, you can always label every other one. That would be 30, so that's 40, 50, 60, 70, 80. We can still understand that you're going up by 10s, even if you are only labeling every other one. Just be careful not to mess up and Okay, so -1 is at 70-ish, so that's about there. 0's at 24, which is about there. Let me go down to 1/8, which is about there. And that's about all I can fit on there. So again, just like last time when we were doing this, even though on this calculator graph, it looks like it just, melts into that x-axis, it does not cross it. It never really touches that. So super important when you're sketching your graph and you're making your graph here, connecting your points, that it's nice and curvy, not chunky. And that you're showing me that it gets, and see, even that's not good because it's kind of touching it. I want it to get really, really close, but never actually touch. And again, I am going to be a little bit of a stickler about that and make sure that your graphs look that way. So again, never actually crossing the x-axis. So very important that you're representing that. Okay, so last but not least, my average rate of change, which hopefully you're remembering is change in y over change in x. It's a terrible y. Between -2 and 1. So again, -2 and 1, those are x values as per the variable in the middle. Going back to my table because I want to work smarter, not harder. -2 is 216. And 1 is 8. So change in y over change in x. Do you think this one's going to be positive or negative based on what the graph looks like? Should be negative because we have a downward or a decreasing graph, in the negative slope if we were looking at a line, but it's not a slope because it's not a constant rate of change, which again, we're going to add in up here. This is still not linear. Again, why? There is no constant rate of change. Those buzzwords, they want to hear it. No constant rate of change. That's exactly what they're looking for when they ask you this question on your exam in June. 216 minus 8 is going to be 208 over -3, which 208 over -3, I don't know. I should probably do it in here so you guys can see it. 208 divide -3 is certainly nothing pretty. Math frac. Oh, not even simplified. So 208 over -3 it is. And that's about it.